all the required code has already been supplied. Here, we'll focus on the stream's code and adding a timestamp extractor to pull the timestamp embedded in the record value payload. Let's kick things off by creating an instance of a timestamp extractor. Implement the extract method. Now, get the electronic order object from the consumer record value field. Next, extract and return the timestamp embedded in the electronic order. Now, go ahead and create the KStream, and go ahead and make the now familiar builder.stream call. Next, add the consumed config object with the surdays for deserialization, but with the twist. We're also providing a timestamp extractor. We could also specify the timestamp extractor via configs, but then it's global for all streams in the application. With this approach, it's local to this stream only. Next, add an instance of the timestamp extractor that you implemented before. Now create a windowed aggregation with tumbling windows, bearing in mind that the timestamps from the electronic order are what drive the action in terms of the window opening and closing. Now calling the aggregate method and initialize the aggregation to 0, and adding the aggregator instance that sums all prices for the total spent over 1 hour based on the timestamp of the record itself. From here, add surdays for the state store via materialized, and convert the KTable from the aggregation into a KStream. Then you'll want to use a map processor to unwrap the windowed key and return the underlying key of the aggregation. Next, add a peek processor to print the aggregation results to the console. Finally, write the results out to a topic. As with the other aggregation applications, let this one run for at least 40 seconds.